All right, so let's look at an example of how to set up an efficiency problem. So one of the big takeaways, or a good place to start, is figuring out what you have to start with and where you're going. And this is a simple dimensional analysis problem. So in order for us to set this up, we know we're starting with oh, that's awful. We'll do it this way. You're starting with 100 watts. So in order to set this up, you will want to convert your watts into kilowatt hours because that's what the cost is measured in. So if we have watts times, in order to do a dimensional analysis, that's 1 kilowatt hour divided by 1,000 watts. You'll then take your 100 watts times your 1 kilowatt divided by your 1,000 watts and multiply that by your 12,000 hours. So how many kilowatt hours would that generate? Perfect. So now you have your 12,000 kilowatt hours, and in order to get cost, you're going to multiply your hours by your cost, which is 0.08. So how much would it cost to run your incandescent light bulb for your 12,000 hours? Okay, so the total is going to be $96, but the question is asking, and we have to be careful, because the question is asking how much would you save, right? So in order to figure out our savings, we would need to take our $96 and multiply that the incandescent light bulb, or the fluorescent light bulb is only going to use 25% of the energy that the incandescent light bulb would use. So we take our $96, and in order to get 25%, we're going to multiply that by 0.25. This will then get us the cost, which should come out to $24. Now keep in mind there's still one more step because we're looking for the savings, not the actual cost. So in order to get your savings, you're just going to take your $96 and subtract the cost, which is $24, to get your total. So you will have saved $72 over the course of the light bulb switch. So if you were to choose your fluorescent light bulb over your standard incandescent light bulb, it would be a $72 savings. All right, so let's look at number 2. Number 2 is asking, if the bulb was turned on for 12 hours a day, how many months before it would need to be replaced? So we're going to have to make an assumption here that isn't provided, that the number of days in a month will be 30. So we'll use that as our average to determine how long would it last. Again, this is a dimensional analysis problem, so it's just kind of a cancel of the units and try and end up with months there. What would be the thing we would want to start with first? Okay, so we would want to start with our 12,000 hours, because that is the life of the bulb. And then in order to kind of move towards months, which is the value we want to obtain, we'll have we know that the bulb is on for 12 hours per 1 day. We also know that there's 24 hours in every day. And we're also going to make the assumption that there's 30 days in a month, and I'm doing a quick side calculation. For every 1 month, you're going to have 720 hours, and that's a quick little calculation you can make to determine hours per day times number of days. So what would be our number of months that light bulb would last? Perfect. So it would last just over 33 months. Perfect. Any questions before we move on? All right, there's one I want you guys to look at for homework, a continuation of 1 and 2. So number 3, if an incandescent bulb costs $1 and lasts 1,000 hours, and a compact fluorescent bulb costs $8 and lasts 12,000 hours, which bulb has the cost advantage and by how much? So spend some time before our next meeting time to look at this question and try and set it up and calculate which one has a better cost advantage for homework. And just as a quick preview, next time we'll look at ways we can reduce energy waste and improve energy efficiency as we continue to talk about these energy calculations and where is the energy going.